Please welcome HP's Chief Technology Officer and Global Head of Labs, Shane Wall.
I am a proud Oregonian. I've lived in this state for the last 38 years. I've raised a family, and I fully intend, as I head into my retirement years, to devote much of my time to how do we drive the future of Oregon and how we can actually make it succeed and take advantages of the technologies around us. I have been fortunate enough to work around the world on many of the most disruptive technologies that we see today. And what I want to do today is talk to you about one of them where Oregon is uniquely positioned. The story actually begins in the past. I want to rewind 150 years, and I want to talk about our ancestors who came here, who settled here in Oregon, and they relied on the blacksmith. So when they needed something done, they went to the blacksmith, he pounded out the exact part, and it matched exactly for what they needed. It was great for the time, but clearly not scalable. Then we entered into what became known as the Industrial Revolution. And for the last 150 years, we have improved this. We've made it more rapid, but it's essentially the same process. Design anywhere, manufacture in a central location where we tend to focus on low cost or automation, and then distribute it everywhere in the world so it can be consumed, where we stage the material in warehouses and in stores and sell it. And it did not matter whether we were doing Twinkies, tablets, or Toyotas. That's the way we did manufacturing. What I'm going to tell you is we're entering a new revolution. And that revolution is mass manufacturing for a segment of one. And Oregon has a chance to be at the center of that revolution. So the basis of this is what's known in the industry as Industry 4.0. It's a fancy term that describes bringing artificial intelligence, robotics, and many of the modern technologies together into one application for manufacturing. But simply described, we call it digital manufacturing. Imagine a world in what you do, you design digitally, everything is digital, you can do it anywhere in the world. And then that design is transmitted wherever it will be consumed digitally to the location of consumption. And then on demand, as needed, you produce exactly what's needed for that locale, and it can be personalized to that locale. This is digital manufacturing and Industry 4.0. It has many benefits and a few implications we need to think about. From a benefit standpoint, it will drive rapid innovation. It will bring the technologies that we see today in order to create entirely new designs we could not have dreamed of. Second, it will significantly improve supply chains. Instead of them now being used to stage material in locations, many of it ultimately wasted, it will be done digitally, where the designs are sent to the location and we significantly improve our supply chains overall. And finally, it's a vision that has no warehouses. It has no storage facilities. It minimizes waste. And in a world where we're thinking about sustainability, it is one of the most profound impacts that we can have. But it has a set of implications, big implications. Taxation. How do we define taxation when everything is digital? Trade. What constitutes an import or an export? What constitutes a tariff in a world that is all digital? And intellectual property. When we print digitally, we can print unique marks into every part. Imagine a plastic part that has its own ID. It's like having its own IP address on the internet, but every plastic part, every metal part can have one. And we can use it then to track throughout the supply chain and throughout a distribution network. Now, on the front end of this digital manufacturing is a whole new way in which we design. Our design today has all been built around subtractive manufacturing. We start with a block of material, and we shave away that material to create the shape that we want to create. But we're limited by how much we can shave, where we can do it. And we create tremendous amount of waste, because all of that material, some of it we recycle, but much of it goes to waste. The second big thing is we're driven by generative design. And that means we use artificial intelligence to look at the requirements of a design, and then we build the design using computers to match the requirements in place. A great example is here on the left. This is a cooling block. The left-hand side is done with traditional subtractive methods. The right-hand piece of it is done with generative design. The part is built up from a set of requirements. And this is very typical of the results we see. A 60% weight reduction, significant savings in the material used, and a 10x better efficiency. On the right-hand side is a whole class of new 3D printers that are used for manufacturing. These are at-scale manufacturing units that are deployed in manufacturing facilities to actually create those parts. And these printers are made here in Oregon. The fundamental technology that goes into them is designed down in Corvallis. Even more stunning with these printers, 50% of the plastic parts in those printers were printed by the printer itself. The printer manufactures itself. And as more metals come online, we'll replace the metal parts in it. And because they're done digitally, we can track every part that is printed. We know where it was printed, we know how it was printed, we know who owns it, we can associate the intellectual rights with all those printers, with all those parts, and as those parts are deployed in our printers around the world, we can track them. And then we can take artificial intelligence and we can actually look at patterns for reliability, where parts will break, where parts are performing well, and we can predict a failure before it happens, and the printer can print its replacement part. This is happening today. This is not the future. Now, this has profound implications across a variety of industries, and we have a few examples up here. This is a center console from a Volkswagen that's being currently manufactured. The gear shift itself is metal, and it is 3D printed. Many of the subsystems, the plastic parts on the side, are all printed with our plastic printers. But you don't have to print just parts, because in a 3D printer, you can print entire subsections that don't need assembly. In the industrial space, I mentioned that we actually print the parts in the printer. These are actually some of the parts that are used in the printer that actually get used to assemble the part. And we can do metals. These are stainless steel 3D printed parts. And this one in particular is very unique in that it was created using generative design. It created a design that is very sparse, but it is stronger than its traditional part, and it is lighter weight, using less material in an industrial application. In the medical domain, there are a tremendous number of applications. I'm using just one here of orthotic inserts. Each one of these is basically an orthotic model of an individual. All of these are individuals that are printed in here, and they're all printed at scale. And not only is it in orthotic space, but imagine the use with earpieces, glasses, stents that can be individually customized, or replacement body parts, knees, hips, and the like. And in the consumer domain, all of these can be done individually. This is a set of orthotic shoe inserts that are all done individually based upon the person. You design it based upon the person's foot, and then they're all amassed together and printed all at once. And then finally, this shoe is a prime example. We have a little industry here in Oregon. The entire sole can be printed, the insert can be printed, And with digital textiles, we can print all of the upper. All of this can be done through digital manufacturing. So let's take a look at one customer. This is a customer called Smile Direct. Many of you may actually use Smile Direct. It revolutionized the orthotics industry, or excuse me, the whole insert industry for braces. And in this case, what you could do is, at about a third of the cost it would cost you for traditional braces, you actually got a set of inserts you used over a period of time, and using AI, it would correct your teeth to way the best visual representation it could get. This is their actual manufacturing facility. One of them. They now have several. They produce 50,000 unique parts a day. That is 50,000 individuals per day. That is 12 million parts on a 24/7 basis. This is what digital manufacturing is about. But beyond the benefits of manufacturing itself, digital manufacturing has the opportunity to make probably the most profound impact on sustainability in the world. If you look at manufacturing today, fully 1/3 of our energy use is consumed in building the stuff we use. And in fact, all those Twinkies, Toyotas, and tablets that we make them in central places for low cost and automation, and then we load them up on ships, or we put them on trains, or we put them on trucks, and we send them all over the world. All of that activity of just moving the stuff we buy consumes 5% of the world's oil supply. If you can design these digitally, transmit it, and on demand in the region which they're going to be consumed, you have the chance to have a 27% reduction in energy savings worldwide. The single largest area where we can make an impact on sustainability. I picked one sector. I could have picked many others. In this case, I picked aerospace. In the case of aerospace, for every 1 pound of weight reduction on an airplane, you can save 100 pounds of fuel, and you reduce by 300 pounds of CO2 creation for 1 pound. You have the chance here to have a substantial reduction in the weight of those planes and the strength of those planes, resulting in a 25% reduction in the sector for energy consumption. It truly can be revolutionary from a sustainability standpoint. What's better is Oregon has many of the key components that can make this a reality. HP, we're not the only competitor. We certainly are the largest manufacturer of 3D manufacturing printers, is based here in Oregon. In Corvallis, all of the fundamental science goes on for 3D printing, and just across the river in Vancouver, those products are manufactured for worldwide use. But it's not limited to us. With people like Siemens and Mentor, we have the computer-aided design capabilities that are moving and working towards generative design that actually give tools that allow you to design in a digital way. And with the likes of Big ML and Agility Robotics, we have a set of startups, many of them in the software domain, that take machine learning, a particular implementation of artificial intelligence, and apply it into the manufacturing space for these exact uses. And on the back end, we have very large companies located here that will see tremendous benefits from that manufacturing revolution. A Boeing and a Daimler. Or in the consumer domain, a Nike or an Adidas. We have all of the aspects to truly create the future of digital manufacturing, the future of manufacturing here in Oregon. It will take some will, it will take some desire on the part of industry, and it will take support from our local government, but we can pull this together and become the leader in digital manufacturing. So finally, I return to that Oregon Trail, to our ancestors who actually came here to create something new. And we have the chance to do it again. We have the chance to go back and remember those roots and use them to create a sustainable world built upon digital manufacturing for the benefit of the Oregon economy. Thank you. Go on this way.
Nicely done.
Thank you.